This lecture we're going to look at solar and lunar eclipses. A lunar eclipse takes place at night, where a solar eclipse takes place during the day. It's important to realize what is the position of the sun, earth, moon before you determine what type of eclipse is taking place. A lunar eclipse takes place when the earth is exactly between the moon sun, and a solar eclipse takes place when the moon is directly between the earth sun. So the relative positioning determines what type of eclipse it'll be. It is safe to look at a lunar eclipse. It is dangerous to look at a solar eclipse. Here's an anatomy of a lunar eclipse. So the moon is being blocked here. A total lunar eclipse can only occur at a full moon, when the earth blocks the sunlight normally reflected by the moon. Some sunlight is bent through the earth's atmosphere, typically allowing the moon a coppery glow. This diagram, not to scale, looks down on the solar system from above. Here we have a picture of a solar eclipse. One must be in the right spot at the right time to see a total solar eclipse. In this case here, there's two terms that are going to come out that we're going to need to identify. And if we notice from before on a lecture, from a prior lecture, that the moon is at a 5-degree angle from the Earth-Sun plane, that it's every time that's in the new moon phase, it does not lead to a total solar eclipse. It's only on the rare occasion. But those are also predictable, and you can follow a lunar calendar to find one of those. It's called the two terms we're going to look at are called the Penumbra and the Umbra. The Umbra is a certain location on Earth, you'll see here, that is completely shadowed or blocking out the sun, where the Penumbra is is still a shadow, but there's still some light being able to, let's just say, pass through. It's not a perfect fit, but it's a pretty close fit. So the Penumbra and the Umbra are simply the locations on the Earth that are being blocked within the shadow of the moon being between the Earth and the sun itself. With the lunar eclipse comes what's called a red moon. The lunar eclipse, in this case, a lunar eclipse occurs when the moon passes through the Earth's shadow. At these times, we see a darkened copper-colored moon, as shown by the inset photograph. The red color is caused by sunlight being reddened and deflected by the Earth's atmosphere onto the moon's surface. This is a form of refraction. When we bend a wavelength and we make it longer, the longer form of the visible light spectrum, or the largest wavelengths, are that of red. So we get this coppery reddish color. An observer on the moon would see the Earth surrounded by a bright but narrow ring of orange sunlight. Note that this figure is not drawn to scale, and only Earth's umbra is shown. There are three different types of eclipses that we can view here. Notice these would be eclipses that would be the total eclipse, right? A total eclipse is where the moon is directly in between the Earth-Sun. This would be a partial eclipse where the moon is just kind of blocking a portion of it. Remember, it's a 5-degree tilt, or it's not on the same plane as the Earth-Sun. It's at a 5-degree axis difference, but on occasion it does slide directly in between us. And then, when I say us, I mean the Earth-Sun position. And then you have the annular eclipse, which is viewed here, where it's not completely blocking the sun, but it's pretty darn close. Here are a few more pictures of a solar eclipse. Once again, the penumbra is the partial eclipse that's seen, that's the shadow around it. And then the umbra, which would be the really dark spot. Here's an actual picture from space where you'd see the umbra as this darkened area, and then the penumbra would be a shadow around it. Here would be a total eclipse, and this would be the annular eclipse, where there's still some sunlight that you can view, but it's not in this perfect location geographically that would be blocking it out. Here, when we look at the eclipse geometry, we'll take it a little step further. If the moon's orbital plane lies in exactly the plane of the ecliptic, right, the ecliptic being the orbit in which the Earth-Sun are moving, as the Earth moves around the sun or orbits the sun, this alignment would occur once a month, but it doesn't. However, the moon's orbit is inclined at about 5 degrees to the ecliptic, so not all configurations are favorable for producing an eclipse. For an eclipse to occur, the line of intersection of the two planes must lie along the Earth-Sun line. Thus, eclipses can only occur at specific times of the year. Only the umbra of each shadow is shown. When we look at the alignment of an eclipse, it's important to realize that every time the new moon phase comes, we do not actually get a solar eclipse. Matter of fact, it's on the rare occasion. It's because of the 5-degree, or technically 5.2 degree, off the ecliptic plane. Right? So the ecliptic plane would be the Earth-Sun relationship, the plane which we've defined as the ecliptic itself. But on occasion, it does pass through the ecliptic, and this is where we get the full moon phase. Excuse me, this is where we get a full full solar eclipse, excuse me. Here are some key terms that help give us a better understanding of what's going on between the Earth-Moon-Sun relationship. The term syzygy is the alignment of the Earth, Moon, Sun, and there's two different types of this, but syzygy is the general explanation of that they are all in alignment. So I have the Sun. Here I have, when it's in conjunction, I have the Moon located in between the Earth, Sun, right? So Sun, Moon, Earth. And when it's in opposition, it's essentially saying the Moon is opposite the Earth, both of which are forms of syzygy. Conjunction, where the Moon is between the Earth, Moon, or the Earth, Sun, and opposition is where the Earth is in between the Moon and the Sun. The Moon's orbit is also like that of the Earth. It is elliptical. The couple of terms that are defined here, apogee is where the Moon is furthest, has the greatest radius in its elliptical orbit, as we learned in Kepler's laws. And we have perigee, which is where the Moon's closest distance from the Earth, or the distance here, my radius is the shortest amount. Both of which just help illustrate how elliptical orbits dominate planetary bodies that are moving or orbiting another object.